Today, we'll discuss about input switches. We have used push button and toggle switches earlier and cover how one can take input through a port. These switches are mechanical in nature and there are spring and plungers in their construction. So basically there is a contact which will connect, a mechanical connection will happen, and due to that there is a major issue of contact going back and forward due to the spring pressure. So when you connect a switch and push it, there are chances that it can read a false reading like this. When you press it, so here it should read a 0, but it is possible it can read this 0, and this 0. So there are chances that multiple zeros will be read. This settling time can be larger as some 10 milliseconds. So you have to take care of this by several methods. So there are basically two methods mainly. This is the actual diagram of how this can happen. Here the switch is off and here it is on. But when one press the switches, this kind of false reading can be there. This is one more example and this is one more example. So you have to take care that you do not read a false reading or a false 0. So for that we are going to use two methods. One is hardware method, the other one is software method. In hardware method, generally people connect a capacitor across the push button. So due to this charging and discharging of capacitor, this type of pulses can be decayed. What will happen when a switch is pressed? The capacitor will start to discharge and it will create a pattern like this. So it will discharge, but it will not reach at this 0. And the other method is a software method. We'll look into the software method. Now we will see the software method. This is a Kale, and I'm going to create a project with 889351. You can use P89351 as discussed in class as well. First, I have to create a project. I will create a new file. Let me add a file. So I have written this program. As you can see, this is our standard library ig51.h. So I am not using it, I am adding it. I have declared a port 1 pin 0 as a switch SW. I have declared an LED at port 1 pin 7. I am using this unsigned character I to generate some delay. So what I am going to do is I will first scan this false 0, and then once I read this 0, I will wait for some time, and then I am going to again read this actual 0. So I am going to read this two times, first at this instant and this instant, and if I satisfy both the condition, then I can going to take the action. So basically I am going to toggle LED if switch is pressed. So I have configured this switch pin as an input pin by writing 1 to it. Then I am scanning the pin P1.0, or you can say a switch status as 0. So if this is true, then it will go inside. That means this, at this point it can be true, at this point it can be true, at this point it can be true. So once it is true, it will go inside. It will wait for some time by having this pulse delay. This is some delay, somewhere around like 10 millisecond delay can be possible. It can be less. It depends on the switch, which type of switch you are using. Depending on that, you have to provide a delay. And then I'm going to again check the status of the switch. If in both the cases I read 0, then I'm going to take this action of toggling the LED. So this is how you can have a key debouncing program, or you can say a software method of key debouncing. So the method, the actual problem is this key bounce. This is the problem, and the solution is key debounce. This is the hardware method, and this is the software method of key debouncing.